With the iPhone 18 Pro Max leaks piling up, it's worth putting it head-to-head against the current iPhone 17 Pro Max to see just how big a jump this next generation might actually be. This isn't a simple spec sheet comparison. The more useful exercise is walking through each major system, understanding what's actually changing and why, and then asking the question that matters most to an actual buyer. Is the difference big enough to justify upgrading, or is the 17 Pro Max still the smarter buy for another year? Before getting into the category-by-category breakdown, it's worth setting expectations about the nature of this comparison. Everything about the iPhone 18 Pro Max side of this is still leak-based rather than confirmed by Apple, while the iPhone 17 Pro Max is a shipping, reviewed, real-world tested device. That asymmetry matters. Leak features tend to sound uniformly positive because leakers and their sources are typically describing intended capabilities rather than final, shipped performance. Nobody leaks the new chip throttles under sustained load, or the mechanical aperture has calibration drift after 6 months, even if those turn out to be real characteristics once millions of units are in the wild. So while this comparison treats the leaked 18 Pro Max specs as the best current picture available, it's worth mentally attaching an asterisk to that side of the comparison that the 17 Pro Max column doesn't need. With that framing in place, let's go through this system by system. Starting with the camera, this is where the gap looks widest, and it's worth spending real time understanding why, since new camera, better photos undersells what's actually being described here. The iPhone 17 Pro Max, like every iPhone before it, uses a fixed aperture on its main lens, relying entirely on computational photography to simulate background blur and manage exposure. This has been true of every iPhone going back to the very first model, and it's worth being clear about what that actually means in practice. The physical opening that lets light into the lens is a fixed size. It doesn't change based on the scene in front of it. Every bit of apparent aperture effect you see in a 17 Pro Max photo, whether that's the blurred background in portrait mode or the way exposure is balanced across a high-contrast scene, is the result of software. Machine learning models estimating depth on a per-pixel basis, image fusion algorithms combining multiple exposures, and various other computational techniques layered on top of what the fixed aperture lens physically captured. This approach has gotten remarkably good over the many generations Apple has refined it. Portrait mode on a 17 Pro Max produces results that would have seemed nearly impossible from a phone sensor a decade ago, and the exposure balancing in Apple's computational photography pipeline handles genuinely difficult lighting scenarios, backlit subjects, mixed indoor lighting, high-contrast sunsets, with a level of consistency that's easy to take for granted. But it's still fundamentally a simulation built on top of a fixed physical starting point, and simulations have edges where they show their seams. Hair and fine detail at the boundary of a simulated blur, backgrounds that don't quite have the optical rendering characteristics of true bokeh, and depth estimation that occasionally gets confused by reflective surfaces, complex overlapping objects, or unusual geometry in a scene. The iPhone 18 Pro Max is expected to introduce a genuine mechanical variable aperture. Physical blades that open and close based on lighting conditions, paired with a new custom Sony sensor. This is a fundamentally different starting point rather than a refinement of the same approach. Instead of capturing a fixed amount of light and fixed depth of field characteristics, and then computing an approximation of what a different aperture would have produced, the 18 Pro Max would be physically changing how light enters the lens before it ever reaches the sensor, meaning the raw data being processed is already closer to what the final image should look like, with far less need for the computational layer to compensate or reconstruct. In practice, that should mean noticeably better low-light shots and more natural-looking depth in portraits, without the phone having to digitally reconstruct what a real camera would have captured optically in the first place. It's worth breaking this comparison down into specific shooting scenarios to make the difference concrete rather than abstract. Low light, side by side. On the 17 Pro Max, a dim scene forces the computational pipeline to lean heavily on multi-frame noise reduction and machine learning-driven detail reconstruction, since the fixed aperture limits how much raw light physically reaches the sensor before software has to compensate. On the 18 Pro Max, a physically wider aperture in the same dim scene means more actual photons hitting the sensor before any processing happens at all, which generally produces a cleaner starting point with less aggressive noise reduction needed. And less aggressive noise reduction tends to mean better preservation of fine texture and detail that heavier processing often smooths